Number 8. Ginger ale doesn't cure nausea. You've probably been given ginger ale when you felt nausea or sick. And for some miraculous reason, this soda can help alleviate it. Scientifically, ginger does have many health benefits. The active compound gingerol accelerates gastric motility, essentially speeding up digestion so nausea doesn't stick around. The remedy isn't wrong, but ginger ale has little to no ginger, so it doesn't have the compound gingerol. Canada Dry once settled a class action lawsuit for falsely marketing themselves as made from real ginger. Their actual process boils ginger in ethanol, which destroys every medicinal compound in it. What's left is carbonated sugar water with a faint ginger flavor. A single 12-ounce can carries over 30 grams of sugar, which actually worsens bloating. The comfort you feel is dopamine from sweetness, nostalgia, and the placebo effect doing all the heavy lifting. So, next time you feel nauseated, use actual slices of fresh ginger in hot water with some lemon. That's the secret remedy. Number 7, dogs are not colorblind. You've probably heard that dogs are colorblind, that they can only see in black and white. It gets passed down through generations of pet owners, but that's completely wrong, and the science proving it has been sitting on the shelf since 1989. Ophthalmologist Jay Knights ran behavioral experiments that showed dogs have two types of cone photoreceptors, sensitive to blue, violet, and yellow wavelengths. Their world is painted in blues and yellows, not monochrome, which is similar to a human with red-green color blindness. Red and green collapse into indistinct brownish tones. That red ball you throw onto green grass essentially vanishes from their field of view. The original myth came from early 20th century comparative anatomy, where scientists reasoned that fewer cone types must mean no color perception at all. A logical inference at the time, but completely wrong. Studies from the University of Padua later confirmed dogs actively prefer color information over brightness when choosing between objects. So while most people think dogs are colorblind, they are actually seeing the world in a different colorful lens. Number 6, chameleons don't change color to hide. Every cartoon you've ever watched shows a chameleon landing on a red flower and turns red, steps onto green leaves and turns green. A living special effect, the ultimate master of disguise. It's one of the most satisfying evolutionary stories of nature, but it's also largely fiction. Evolutionary biologist Devi Stewart Fox published a study that dismantled the camouflage narrative. Across 21 lineages of dwarf chameleons, the species capable of the most dramatic color change were consistently the ones using it to signal other chameleons, not to hide from predators. The degree of color change had no correlation to habitat variety. It correlated entirely with social competition. Male-veiled chameleons that achieve brighter head coloration during confrontations are statistically more likely to win. The speed of the color shift predicts dominance. The mechanics are extraordinary. Chameleons have these specialized skin cells called iridophores that contain nanocrystals of guanine. Relaxed, those crystals reflect blue-green light. Aroused or threatened, they spread apart and shift the display toward oranges and reds. So chameleons aren't changing colors to hide. It is their biological broadcasting system. Number 5, alcohol doesn't kill brain cells. The idea that alcohol destroys brain cells is one of the most common misconceptions. It's because heavy drinking visibly damages cognition. It causes you to slur, lose your balance, and behave in a way you otherwise wouldn't. So surely the cells themselves must be dying. But what alcohol damages are dendrites, the branching extensions at the tip of each neuron that receive signals from neighboring cells. Damage those, and communication across the brain breaks down, which directly affects your cognitive functions. Your memory slips, and your coordination to move deteriorates. But the actually neuron itself does not die. Studies have shown that when someone stops drinking heavily, the brain begins to recover, dendrites regrow, and neurogenesis continues. And heavy chronic drinking does cause real harm through thiamine deficiency and inflammation, but alcohol degrades the wiring and communication, not the building. So drinking alcohol is okay as long as it is in moderation. Number four, holding in a sneeze is actually dangerous. Most people suppress a sneeze out of basic politeness. A quiet room, a first date, or a job interview. The sneeze builds, you pinch your nose and let it out quietly. It feels completely harmless. And it has become such a reflex that almost no one thinks twice about it. But a 34-year-old man had been suppressing sneezes for most of his adult life until one day he felt a pop at the back of his throat. Within hours, he couldn't speak or swallow properly. His throat had swollen around a small perforation, air bubbles tracked into the surrounding tissue, and he spent 2 weeks in hospital. A normal sneeze releases roughly 1 kilopascal of force at up to 100 miles per hour. Seal that pressure inside with a pinched nose and a closed mouth, and it multiplies over 20 times. It is forced inward through the eustachian tubes into the sinuses against the eardrums. Boston University researchers reviewing 70 years of sneeze injury literature documented ruptured eardrums, burst blood vessels, diaphragm damage, and cerebrovascular complications. So, next time you need to sneeze, just let it out. Just make sure you aren't doing it directly on anyone. Number three, eating before bed doesn't automatically make you gain weight. There is a guilt that comes with eating late at night. You've probably heard that metabolism slows and calories get stored as fat while you sleep. But that's not completely true. A 2007 study gave obese women identical calories spread across morning only and evening only windows over multiple weeks. Weight changes were statistically the same across both groups. Basal metabolic rate during sleep remains close to daytime levels. The body does not stop processing food at sunset. A Harvard study did find that eating 4 hours later in the day raised hunger hormones and reduced daily calorie burn by about 59 calories, with some molecular shifts in fat tissue favoring storage. So, timing is not completely irrelevant to metabolism, but 59 calories a day is not a material difference. No study has ever shown that eating at midnight causes weight gain that eating at 6 p.m. would prevent. So, next time you are enjoying a movie and feel an internal guilt of eating, don't sweat it and enjoy yourself. Just make sure you aren't excessively overeating and falling asleep feeling bloated. Number two, hypnosis is not a mystical trance state. You've probably seen the shows of people on stage, the swinging pocket watch, the volunteer clucking like a chicken, and the hypnotist snapping its fingers, commanding the subject. It has been theatrically sold for so long that even self described skeptics tend to believe some part of it. But this idea of being lost in a state of hypnosis without any control is logically impossible. But here's the thing, hypnosis is real. It's clinically useful and evidence backed for pain management, anxiety reduction, and behavioral change. Although neuroimaging studies do show measurable changes during hypnotic states, including reduced connectivity between the anterior cingulate cortex and prefrontal regions, but those brain changes are not required for hypnotic suggestions to work. Highly suggestible individuals respond equally well with or without any formal induction. What hypnosis consistently produces is focused attention, reduced peripheral awareness, and heightened responsiveness to suggestion. Those are properties of ordinary waking cognition, just selectively amplified. So the people you see hypnotized are the people that volunteered willingly. It's like a placebo effect of believing and expecting it'll work, making you more easily suggestible. Number one, the Big Bang is not the origin of the universe. Most people believe that the Big Bang is the scientific answer for where the universe came from. It is one of the most successful theories in the history of science. This model describes, with mountains of supporting evidence and extraordinarily well, what happened after the rapid expansion of a hot, dense, early state of spacetime into the universe we observe today. What it cannot explain is the origin of that initial state itself. When cosmologists attempt to push the model back to t equals 0, the initial singular point when the Big Bang began, general relativity breaks down. And general relativity is the backbone of the Big Bang cosmological theory. So, scientifically, the Big Bang only explains the universe's evolution. There's a universe before the Big Bang. We just have zero clues or ideas. Thanks for watching. Like and subscribe to see more.